solve few important and very interesting sums where we are going to use trigonometrical identity. Let's see the sum. It says choose the correct option and justify your choice. The question is 9 sec square a minus 9 tan square a. We have to see whether it is the value of this is going to be option A, B, C or D. So let's solve it first, right? So we have 9 sec square a minus 9 tan square a, and in this expression, in this binomial, you know we have got 9 common there, right? So let's take 9 common. So into bracket it would be sec square a minus tan square a. Now think, have we learnt any identity where you have sec square a and tan square a? Yes, we have an identity, that is 1 plus tan square a is equal to sec square a, and from that identity we had learnt sec square a minus tan square a is nothing but it is equal to 1. So we substitute that value here, so we'll get 9 into 1, right? Why did we write 1? Because we know sec square a minus tan square a is equal to 1. What is 9 into 1? It is 9, and that is nothing but your option number B. That means here option B is the correct answer, right? Now let's do another sum which is even more interesting than this, right? Let's see that. It is now we have to check for this particular expression, that is sec a plus tan a into 1 minus sin a. To check for this, the value is whether it is option A, B, C or D. Let's see that now. So let's write down the expression first. Sec a plus tan a into 1 minus sin a, right? In the first bracket, you have sec a and tan a. And in the second bracket, you have sin a, right? That is a primary basic ratio. So let's do one thing. The first bracket, that sec a and tan a, let's convert them into sin and cos. So that means there sec a can be written as 1 upon cos a. Beautiful. And tan a can be written as sin a upon cos a. Right, and into the next bracket it is already sin, so we keep it as it is nothing but 1 minus sin a. Now when you solve the first bracket there, the denominators are same, so we keep the denominator as it is. The numerator would be now 1 plus sin a, right, into the other bracket, that is 1 minus sin a. Now we have to multiply this to fractions where, right, that means you are going to multiply the numerator. Now if you observe the numerator here, that is what you are going to multiply. Identify that algebraic expression. See there very carefully. The first term in the first bracket, if we take it as A, the second one as B, and it is A plus B, that means the first bracket. And if you see the next bracket there, it is nothing but it is A minus B. That means this expression is in the form of A plus B into A minus B, for which the answer is A square minus b square. So we use that, and according to that we would get 1 square minus sin square a upon in the denominator, that is cos a, right? Simple till now, right? Now the question is 1 square will remain as 1, right? So we get it as 1 minus sin square a upon cos a. Now the question is, what will you do further? So can we get the value of sin square a? Yes, we can get it from an identity which we had learned, the very first identity. Sin square a plus cos square a is equal to 1, right? Now from this identity, what is sin square a plus cos square a? We know it is equal to 1. So that means we can write it as 1 minus sin square a is equal to cos square a. So we got that value, that is 1 minus sin square a is nothing but cos square a upon cos a, right? Now cos square a upon cos a, that means cos a and cos a gets cancelled. So what we get is nothing but cos a, right? If we expand it further, it would be cos a into cos a upon cos a and cos a gets cancelled. So the answer which we get is nothing but cos a, and that is the final answer which you get. Identify which option is this. This is nothing but your option number D. That means here option D is the correct answer which we have. Wasn't that easy?